Hi, and welcome to this GCSE maths lesson, maths/physics lesson on distance time graphs. Now, distance time graphs are where we plot distance against time, and we use them to describe the motion of an object. So this might be a person or something that is moving, and we plot their motion on a graph. Now, there are lots of things we can tell from a distance time graph, and to help us, I am going to talk us through an example of a distance time graph. So on this graph, you can see that we have distance on the y-axis and we have the time on the x-axis. Now, in this particular example, it is given the time in hours. So from 9 o'clock all the way through to 6 o'clock, it might give us the time in seconds or minutes or hours from the start of our journey. But in this example, it's given us the actual times of day. Now, there are lots of different sections on this graph, so we're going to have a look at each one in turn. Now, between 9 and 10 a.m., the person doing this journey has travelled from 0, presumably their starting point, to 6 miles from home. And they've done that in a straight line. Can you see that it's a straight line on the distance time graph? Now, we can use the gradient of that section of the line to work out the velocity, the speed at which the person or object was moving. So if they've moved 6 miles across 1 hour, we could say they are moving at 6 miles per hour for that first section of the journey. Between 10 a.m. and 12 p.m., they don't move any distance. This means that they are stationary. They are stationary, they are not moving, they are at the exact same spot. From 12 p.m. until 1 p.m., they move from 6 miles to 10 miles. So they move 4 miles over an hour. And so, as we know, speed is distance over time, which is the same as the gradient of the graph. That means that they're moving at 4 miles per hour. Between 1 and 2 p.m., they are stationary again at a point 10 miles away from home. We then see them travel back to be closer towards home. So they travel again at 4 miles per hour between 2 and 3 p.m. They then travel again away from home between 3 p.m. and 5 p.m. And they travel back again from 5 p.m. to 6 p.m. What this means is that any horizontal sections, any flat sections on a distance time graph are when something is motionless, when it's still, it's stationary. When I have something that is moving with a positive gradient, a positive straight line, just like the sections over here and here, these are when my object or my person is moving at a constant velocity. Okay, they are moving at a constant velocity. And that velocity would be positive in the positive direction. If we have something like this section here and this section here, where the slope is in the opposite direction, it's a negative gradient, that means that they are moving at a constant negative velocity, usually because they're traveling in the opposite direction. And that is distance time graphs. We have to be able to interpret them. Now, we also have to be able to draw them. And an example of that is given in the worksheet that accompanies this video, but it's exactly the same. We think about the motion that is happening and we use that to plot our distance time graph. So that was a very quick summary of distance time graphs. I thoroughly encourage you now to go and have a go at the worksheet. The link for this is in the description of the video, all totally free. Go and have a practice. There are work solutions available as well, and that will help you to fully get to grips with distance time graphs. Thank you guys for watching. I hope you enjoyed that, and I will see you next time.